Question 20. Draw a minimum of 5 electric field lines, okay, from the plate. Now you could use these points here. The point is they must be right angles to the point here where they leave. That's got to be at a right angle. Okay, 90 degrees. If you want to do one from there, it's going to go in that direction there. That's still a right angle. Here they're all right angles. Here it's a right angle. They're going to end up hitting these plates, and these must also all be at right angles. Now, I don't have to get it perfectly, but by sight that should be about right. So that's first mark. It's a 2-mark question. The second is the direction, always from positive to negative. So 1, field shape correct. 2, everything has a direction. Define electric potential. Now you just again have to learn this. This is the work done per unit charge. Okay, that's only half of it. It's to bring a positive charge from infinity to the point. I guess you could say from a negative charge from the point to move it to infinity, but that's the standard definition. Again, you just need to learn it. Sphere is given positive charge by connecting it to a power supply. Electric potential is 5 kilovolts, 5000 volts. Sphere has radius 1.5 centimeters. Show the charge is this value here. So, potential is going to be Q over 4 pi epsilon 0 R. So rearrange Q is just going to be 4 pi epsilon 0 V. Stick the numbers in, and we end up with Q is 8.3 times 10 to the minus 9 coulombs. Do remember that's 5,000 volts, 1.5 centimeters, 1.5 times 10 to the minus 2 meters. Everything else should be fine. See part 2. Charged sphere suspended from a nylon thread. The weight of the sphere is 1.7. There you go. Let's put it in. 1.7 times 10 to the minus 2 newtons. Okay. Now, show that the electric force is 1.2. Okay. What we're trying to find is what is the force in this direction. Okay. Now, if you look at the triangle, we've got this vertical side, 1.7 times 10 to the minus 2. I've got this angle here. This, therefore, is the adjacent side. That's the opposite side. We want the opposite side. We are going to use tan. A number of you made the mistake using sine or cos. So, sticking the numbers in, the electric force is just going to be the weight, 1.7 times 10 to the minus 2, tan theta, tan 4 degrees, and if you work that out, that's 1.2 times 10 to the minus 3. Again, don't use sine or cos. Part 2. Calculate the field strength E between the parallel plates. Okay, well, E is just F over Q. Remember, FEC for parallel plates. So we're just going to have 1.2 times 10 to the minus 3 divided by 8.3 times 10 to the minus 9, and that gives us a field strength of 1.4 times 10 to the 5 newtons per coulomb. 2 marks.